Hello all. On this occasion, I will discuss Pure Math 1 that is from October-November 2019, question number 6 and question number 7. We start with the question number 6. Given that x more than 0, find the two smallest values of x in radians for which 3 times tan 2x plus 1 equals 1. So all necessary working. Now from here, do tan 2x plus 1 equals 1 divided by 3. Yeah, do tan 2x plus 1 equals 1 over 3. Now tan plus means that is angle in the first and third quadrant. Then first we calculate the basic angle of this equation, that is shift tan 1 over 3. That is this one, shift tan 1 over 3, and that is by using calculator we obtain that the basic angle is 0.32175 radians. Basic angles here, that is angle here, alpha, and this one. Now the first angle or the first solution for this equation, that is this angle 2x plus 1 equals, here is this, the first angles, that is x, that is equals with this basic angle, thus 2x plus 1 equals alpha, and alpha is this one. Thus from here we calculate x, that is alpha 0.32175 minus 1 divided by 2, we obtain x is minus 0.339, which is less than 0, thus which is rejected because here is x more than 0, that is the domain for this equation. Thus the first x is rejected, and the second that is 2x plus 1 equals, thus actually this x, that is pi plus basic angle, that is alpha plus pi, and then from here we obtain that x is 1.23. that is satisfied because this is x already more than 0, and then another value of x we can calculate it by 2x plus 1 equals alpha, thus this basic angle, plus 2 pi. Yeah, thus pi actually that is the period of tan. Yeah, thus 2x plus 1 equals alpha is 0.32175 plus 2 pi, and then from this equation we get x is 2.80. Thus the answer for this, the two smallest values of x, that is 1.23 and 2.80. B, the function fx equals 3 cos squared x minus 2 sin squared x is defined for x in between 0 and pi inclusive. Express fx in the form a cos squared x plus b, where a and b are constants. Now thus fx is this one, 3 cos squared x minus 2 sin squared x. We use identity, this is identity, sin squared x plus cos squared x equals 1. Thus we can replace sin squared x by 1 minus cos squared x. Thus sin squared x here is equals 1 minus cos squared x. Thus sin squared x here is substituted by 1 minus cos squared x. Thus fx is 3 cos squared x minus 2 times 1 minus cos squared x. Thus 3 cos squared x minus 2 plus 2 cos squared x. Thus 3 plus 2, that is 5 cos squared x minus 2. Now II for question B, find the range of f. Dus find the range of fx. Fx is 5 cos squared x minus 2. Thus the value of fx depend on the value of cos squared x. Now the sketch for y equals cos squared x already sketched here. Thus from here we can see that the value of cos squared x, that is minimum is 0, that is when x is pi over 2, and maximum 1, that is when x is 0 or pi. Now fx minimum, the minimum value of fx happen when the value of cos squared x is 0, that is here. Thus 5 times 0 minus 2, that is minus 2, and fx maximum when the value of cos squared x is 1, here and there, that is thus cos squared x is 1, thus 5 times 1 minus 2, thus 5 minus 2 is 3. Thus the range of fx, that is in between minus 2 and 3 inclusive. Thus the smallest value of fx, that is minus 2, and the greatest value is 3. Now question number 7. The diagram shows a three-dimensional shape OABC, DEFG. The base OABC, this is the base OABC, and the upper surface are identical. Upper surface DEFG are identical horizontally rectangles. This is the upper surface. Okay. Now the parallelograms OAED and CBFG, this parallelogram and this one, both lie in the vertical planes. Points P and Q, this and that, are the midpoints of OD and GF respectively. Thus P is midpoint of OD and Q is midpoint of GF. Now unit vector I and J are parallel to a vector OA and vector OC respectively, and the unit vector K is vertically upwards. The position vectors of A, C, and D are given by a position vector of A, that is OA, 6i, and position vector of C, that is OC, 8j, and vector OD is, this is vector OD is, that is 2i minus 10k. Thus vector OA, that is this one, that is 6i, and vector OC, this is 8j. Now question I, express each of the vectors PB and PQ in terms of ijk. Thus vector PB, this is, that is from here to that, is initial to terminal B, and the vector PQ, that is this here, vector from P to Q. Now from this diagram we can see that vector PB, that is vector PO plus vector OB. This vector PB is vector PO plus PB. Now vector PB, actually that is half of vector OD but in opposite direction. That is why vector PO, that is equals minus vector OD per 2. Thus minus sign here means vector PO is, that is in opposite direction with vector OD plus vector OB. Now minus vector OD divided by 2, this is minus vector this divided by 2, thus that is minus I minus 5k, and vector OB, follow this vector OB, that is vector OA plus AB, and vector OA, that is 6i, and vector AB, that is equals vector OC is, that is 8j. Thus vector OB is 6i plus 8j. This one. Now minus I plus 6i 5i plus 8j minus 5k. This is the vector PB. Vector PQ, from here to there, that is equals vector PD plus vector DQ. Now again here we see that vector PD, because P is the midpoint of OD, that is half of vector OD. Thus PD is actually vector OD divided by 2. This is, yeah, thus vector PD is vector OD divided by 2. And vector DQ, that is, yeah, this part actually, that is half of vector OA. Yeah. Thus vector OD, that is this one divided by 2, thus that is I plus 5K, and vector DQ, that is DG plus GQ, and DG, that is 8J, and DG, that is half vector OA. Yeah, that is half times 6I, that is 3I. Yeah, this is the vector vector DQ, that is DG plus GQ. Yeah, 8J plus 3I, that is here. No, I plus 3I, that is 4I, 8J plus 5K. This is a vector PQ. II, determine whether P is nearer to Q or to B. No. We want to find the length of line PB. Yeah, thus the length of line PB, that is magnitude of vector PB. That is actually magnitude of vector PB, that is magnitude of this vector, that is square root of 5 square plus 8 square plus minus 5 squared, that is square root of 114, or that is 10.7 correct to 3 significant figures. And the length of line segment PQ, that is magnitude of vector PQ. Thus that is magnitude of this vector, that is square root of 4 squared plus 8 squared plus 5 squared, that is square root of 105. Approximately 10.2 correct to 2 significant figures. Thus we can see here that distance P to Q is less than distance from P to B. Thus P is nearer to Q. III, use a scalar product to find angle BPQ. No, thus here we will use the scalar product of vector PB dot vector PQ, that is per definition equals magnitude of vector PB times magnitude of vector PQ times cos theta, where theta is angles between a vector PB and vector PQ. Yeah, that here is the illustration of a vector PB, vector PQ, and theta. Theta is angle between vector PB and PQ. Now, vector PB dot vector PQ, this vector dot vector, that is 5 times 4, 20, plus 8 times 8, that is 64, plus minus 5 times plus 5, that is minus 25, equals magnitude of vector PB, that is square root of 114, times magnitude of vector PQ, that is square root of 105, cos theta. Theta is the angle between vector PB and vector PQ. By using calculator, we obtain that theta, that is 1 radian, or that is 57.4 degree. That is all for discussion today. See you in the next video. Thank you.